This section is an introduction to different types of quadrilaterals and how to classify them. So a good way to look at the differences initially between these is in this Venn diagram. We have quadrilaterals within this entire circle. Within quadrilaterals, you have different types. There's kites. We have trapezoids is the T, and parallelograms. Within trapezoids, we have isosceles trapezoids. Within parallelograms, we have rectangles. We have rhombuses or rhombi. And then the things that are both rectangles and rhombi that intersect there are the squares. So, for instance, anything that's a rectangle is also a parallelogram, also a quadrilateral. Anything that's an isosceles trapezoid is also a trapezoid and a quadrilateral. If you're a square, a rhombus, a rectangle, a parallelogram, and a quadrilateral. All that goes together. We'll be looking at much more detail about the different properties of these things over the next several lessons, but just sort of to get started, parallelograms have, among other things, these 5 things true. The opposite sides are parallel, opposite sides are congruent, opposite angles congruent, consecutive angles supplementary, the diagonals bisect each other. For a rhombus, everything about parallelograms are also true for rhombus. In addition to that, all 4 sides are congruent, plus other things we'll get to later about such as the diagonals being perpendicular. So also diagonals, perpendicular is one we're going to use a little bit later. Rectangles are parallelograms, so all this stuff is true, plus they have 4 right angles and other things as well. Squares are rectangle, rhombuses, and parallelograms, so everything true above is true for a square. Trapezoids are not parallelograms, only one pair of opposite sides are parallel, and isosceles trapezoids have the same characteristics as trapezoids except what we call the legs, the 2 pieces that are not parallel are congruent, and then a kite, the adjacent sides are congruent, and other things are true such as perpendicular diagonals again. So again, we'll go into much more detail later, but this is just to get it started. So for instance, here we have a rhombus, and we want to find values for A and B. Now in a rhombus, all 4 sides are the same length. So you can set any 2 sides the same, and you know that it should work out. So for instance, we can say 5a plus 4 is equal to 3a plus 8 because we know those 2 have to be the same. Subtract 3a from both sides, subtract 4 from both sides, so a is 2. And then we know these 2 have to be the same as well, so we set those equal to each other, and we solve for b, and b is 4. So this is just the idea that you can use these properties and then develop algebraic equations from them and solve it that way. And some of these quadrilaterals later on will be classifying just by inspection, just by looking at them, and some of them will actually try to prove it using a fair amount of algebra. And so some of that algebra is going to involve these formulas, the distance formula, midpoint formula, and slope formula. And so rather than go through each one and say each one, I'll leave this up here for just a moment, so if you need to refresh your memory, you can. So distance formula between 2 points, midpoint formula is the midpoint between 2 points, these 2 points here, and the slope formula is the slope between these 2 points. You can do it either way. So this is an example now of how you could classify a quadrilateral algebraically rather than just looking at it. So when we look at this quadrilateral given by points A, B, C, and D, which I've rewritten here, looks like it's probably a square, but you can't be sure yet. There are many, many ways to prove what it is. I'm going to use a method that involves the diagonals. Now, first let's prove that we have a parallelogram, or see if we do. The diagonals of a parallelogram bisect each other. So these things should bisect each other. If that is true, they should have the same midpoint. So we'll take one diagonal, AC, another diagonal, BD, and find their midpoints. So we add up the x's, divide by 2, add the y's, divide by 2 for AC, and we get 0, 1. Then we do the same thing for BD. Add the x's, divide by 2. Add the y's, divide by 2. We get 0, 1. Therefore, we must have a parallelogram because same midpoint, so they bisected each other, parallelogram. Now let's see if we have a rectangle. Well, a property we'll talk more about later when we get to rectangles more formally is that the diagonals are the same length. And so now, if we want to check length, we use the distance formula. And so we find the distance from A to C. So here's the distance formula. You get rad 52. Now the distance from B to D, distance formula, plug it in, and you get rad 52 again. Therefore, not only is this a parallelogram, it is also a rectangle. All right, could also be a square. Now, before we get to that, let's see if it's a rhombus. One thing true about rhombus is the diagonals are perpendicular. If you want to show that things are perpendicular or not, you use slope. So now we do the slope of the diagonals. So slope of AC, change in y's over change in x, and we get negative 2/3. Slope of BD, change in y over change in x, and we get positive 3/2. These are negative reciprocals, therefore we have a rhombus. And if you recall, anything which is both a rectangle and a rhombus must be a square. And so because we've determined a rectangle and a rhombus, we know finally it's also a square. So that's doing it somewhat exhaustively as far as using the properties. Let's do a couple more of those, and then we'll do some by inspection, which are definitely easier. Okay, here we have what looks like it's probably a parallelogram, maybe a rectangle, we're not sure. I recopied the points down here, and again we're going to do the diagonal method. So I've got the midpoint of AC, it's one diagonal, and I get 7/2, 5/2. Then I'll do the midpoint of BD. So I add x's, add the y's, divide by 2, 7/2, 5/2, so I know it's a parallelogram. Now let's see if it's a rectangle by finding the distance BD and the distance AC. Again, if the diagonals are the same length, we know it's also a rectangle. And so distance formula for AC, I get rad 34. Distance formula for BD, I get rad 26. They're close, but they're not the same, so therefore it's not a rectangle. So I know I just have a parallelogram. Now this one looks like it's probably a kite, and I can't use the same method I would use for parallelograms because I know it's not going to work already. But for a kite, I know the adjacent sides are the same length. So if I can show that AB and BC are the same, and then AD and CD are the same, then I know I've got a kite. So I just use distance formula. So from A to B, distance formula, rad 20, B to C, distance formula, rad 20, C to D. So now I'm not doing diagonals. Not diagonals, I'm doing sides. So C to D, distance formula, rad 65, and D to A, same thing, rad 65. And so what I've shown is the adjacent sides are the same lengths, so I have a kite. So we use the distance formula to show that AB and BC are the same, and AD and CD are the same. Okay, a couple more examples already solved. For this one here, we found the midpoint, the diagonals, midpoint. So midpoint of AC, 9/2, 7/2, BD, 9/2, 7/2, so parallelogram. Checking it's a rhombus, I do the slope of the diagonals. This one is a slope of -1, this is a slope of +1. They're negative reciprocals, so it's a rhombus. And then one more like this before we just do it by inspection. This one, these might be parallel, but you know these aren't. They don't look like it, at least, so it's maybe a trapezoid. So we want to see if they're parallel, so we check the slopes. This has a slope of 1, this is a slope of 1, same slope, so they're parallel. One set of sides parallel means trapezoid. All right, now for these problems, it's just a matter of classifying it by appearance. Okay, you don't have to go through all the same amount of trouble we did before. Now number 3, it doesn't appear that these sides are parallel. These don't seem parallel at all either. So I would say this is just a quadrilateral. It doesn't seem like it's a kite because these aren't the same length either. Over here, opposite sides seem parallel, but they're not the same length, the adjacent sides, so it's not a rhombus. And they're not right angles on the side, so it's not a rectangle. So I would say this is probably just a parallelogram, and of course then a quadrilateral. Over here, this looks like a kite and a quadrilateral. This one looks like a rectangle, which means it's also a parallelogram and a quadrilateral. This is a trapezoid because we've got one pair of opposite sides congruent. Also, these look like the same length. So I'd say isosceles trapezoid because these are the same length. Trapezoid because these are parallel, and then quadrilateral. And then here we've got, looks like a square, which means it's also a rectangle, a rhombus, a parallelogram, and then a quadrilateral as well. And finally, we want to find the lengths of these sides. It's a parallelogram, so therefore opposite sides are the same length. So I'll say 2m plus 8 is equal to 3m minus 1. Add 1 to both sides, subtract 2m from both sides, so m is 9. So if I plug 9 back in, I'm going to get 2 times 9 is 18, and 8 is 26, so that makes this 26. And if I plug 9 in over here, I'll get 5 times 9 is 45 minus 2 makes 43. So now I've got s plus 1 is 43, so therefore s is 42, because these sides have to be the same too. So they're both 43, so 43, 43, 26, 26, m was 9, and s must have been 42.